Namaskara. In this video, the concept is division. Let us see how do we enlighten the children about division. NCERT has given specific guidelines about the topics for children from classes 1 to 5. Students by the end of 5th standard should clearly know the concept of division. Subsequently, when division of large numbers is given as a problem, they have to solve it. But why is division a confusing concept for children? Why does it cause so much of confusion? Children, while solving division problems, they have to do it according to place values. That is, each number should be divided according to its place value. Carrying out division without place value is a common mistake. Also, children should know the rules of division. Just as multiplication has its rules, division has its rules. They have to keep them in mind and learn division. Lastly, division is mugging the tables, which is a misconception among children and teachers. This is why the concept of division comes across as difficult for children most of the time. If I were to effectively teach the children the concept of division, what guideline should I be following? Within what framework can I teach them this concept? If we look at it, division, I have to divide according to place value, that is number one. Another, why should I start division from the biggest place? What is the reason for that? Subtraction, addition, everything starts from the small number, that is from the unit place. But why should I start division from the biggest place? Students need to understand this aspect completely and thoroughly. Lastly, division is simplified subtraction. Now, to teach division, let us see what are the TLMs that can be used to teach division. First, these are square counters, these are yellow cubes, this number line, and 1 rupee play money. This TLM is relevant for classes 2 and 3. How do we make them visualize division? We can start with these tools. For classes 3, 4, and 5, we can use base 10 blocks and play money up to 1000 rupees. Now, let us begin with these square counters and see how we can bring in the concept of division. And later, we use these yellow cubes and the number line. Now, these square counters. I have 1, 2, 3, 4, 5, 6, 7, 8 square counters. I have to distribute these counters to 4 friends. While distributing, let us imagine these are chocolates. Can I give more to some of them and less to the others? No. Distributing. Dividing means equal distribution. Let us also see how many will they get and how many would remain with me. Let us see. I have 8 square counters and I have to distribute it to 1, 2, 3, 4 friends. What do I do first? I start by giving 1 to each of them. Would all pieces be gone? Or will I be left with some? There are some remaining, so I will give 1 more again. Earlier they got 1 each, now they have 2 each, and I have nothing left. All 8 are distributed among 4 friends. How many have each got? 2. Did everyone get 2? Yes, everyone got 2. Nobody got more, nobody got less. I have 12 burfies. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. These 12 burfies have to be distributed to 3 of my friends. To 3 of my friends. How do I distribute them? Since I have 12, will they get 1 or more? Definitely more. So, let us start with 2. This is because I already know I have many more than 3. Therefore, let us give them 2 each. Did something remain? Yes. Do we have some more? What shall we do? Let me give them 1 more. Will it all go? Each one has got 1 more. I still have some more left. Can I give them? Yes. 3 people are there. I have 3 burfies. So if I distribute 1 each, how many did they get? How many have remained with me? I had 12 distributed to 3 friends. All got 4 each. Did anyone get more or less? Everyone got equal quantity. That is 4 burfies each. And I have nothing left. So, what did we do now? Whatever we had, we distributed to the people, equally distributed. We can try the same thing with the number line. That is the chain of red and white beads. Let us see that. In this number line, I have 20 beads. These 20 beads have to be equally distributed to 4 people. How do we do that? I give 1 to 1 person, but I cannot move it out of the string. How do I do it? I have 20, all 20 have to be given. As you have seen earlier, when we distributed, nothing remained with me. All my friends got equal share, but I am not left with anything. What is the best way to make the children understand the concept? If I give 1 and there are 4 people, there are many more remaining. What if I give 2 each? How many people are there? 4 people. We need to know in advance as to how many people are there. Even if I give 2 each, I have so many left. So, what if I give them 3 each? What if I give 3 to each person? I still have some more. What if I give 4 each? Let me give them 4 each. I gave them 4 each, but still I have some left. Probably, if I give them 5 each, will it be over? Yes. Now I have nothing left. How many did each get? 5. 1, 2, 3, 4, 5. Did everyone get it? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So everyone has got 5. No one got less, no one got more. What did we do in this distribution or division? We began with a guess. Will it be over if I give 1 or will it be over if I give 2? In the same way, we did repeated subtraction. That is, we subtracted the same quantity again and again. We thought of giving 2 each and 3 each and 4 each. Only when we gave 5 each, all beads were empty. Till then, we had some beads remaining. Repeated subtraction is simplified division. To understand this, we should already know how many beads will each person get. It means only if we know the answer through division, it becomes easier to carry out repeated subtraction. But what is division? It is distribution. How much will each person get? I will know only after distribution. Hence, we tell them about repeated subtraction at the very end. Now, let us distribute these burfis to 4 people. Let us see how many burfis do I have and how many people should I distribute. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I have to distribute these 13 burfis to 1, 2, 3, 4 people. To begin with, I will give them 2 each. I have many burfis, so I thought 2 each would make it 0, but no. Then I will give them one more and see if it would become 0, because when I distribute, everything should be given, but I am left with 1. All have got 3 each. This fourth one nobody will get, because then it cannot be equal distribution. If I give here, he gets 4 and the rest will get 3. So this one, in division, when something remains, we call it the remainder. Now let us try the same with play money. 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 rupees. I have to distribute these 9 rupees equally to 4 people. 1, 2, let us give 1 each, and then let us try giving 2 each. I have 1 left with me. What is left is called remainder. What each person got equally is called the quotient. That is, what you have got is called the quotient. Now, when we take a large number and distribute it, how do we distribute? That is, if we move from 1 digit to 2 digit numbers to 3 digit numbers, and if we were to distribute it, how do we do it? I have here 1, 2, 3, 4. 4 hundreds and 1, 2, 3, 4, 5, 6 tens. 460 and 1, 2, 3, 4 units. 464 base 10 blocks are there. I have to distribute it to 4 people. Distributing means I have a big number here. I will distribute according to place value. Till now, we did not use place value. Now, let me write it down. 464. This is units place, this is tens place, and this is hundreds place. Where should I start distributing from? Should I start from units or from tens or from hundreds? This is a rule of division. Division has to start from the highest place value. Which is the highest place? 100 here. So, I have to start from hundreds place. What happened? I am a teacher, so you have to do what I ask you to do. But for subtraction, addition and multiplication, you started the process from unit place. Start from the least place value. That is what we learnt. But now, we have to start from the biggest place for division. Why should we do it? Let us listen to a story. Now here, I have a basket on my head and this is in it. This is a jackfruit, this is mango and this is lemon. All this, that is 4 jackfruits, 6 mangoes, and 4 lemons. I am carrying this in a basket on my head. I have to reduce the weight on my head. Which is the first item that I should take out to reduce the weight? Will the weight reduce if I take out the lemons? Will the weight reduce if I take out the mangoes? Or will it reduce if I put down the jackfruit? When you ask this question, what will the children say? Jackfruit, because among the fruits here, the heaviest is jackfruit. Therefore, only if I take out the jackfruit, the burden on my head would reduce. So, if I distribute the 4 jackfruit first, I will be left with 6 mangoes and 4 lemons. Then the weight on my head will reduce and it becomes light. So, from this story, we can understand why we should begin from the highest place value. This is how we can address the confusion or questions among the children. This is the story. Then, if we understand this, let us proceed to the next process. Now, I am going to distribute the 464 base 10 blocks to 4 people. I will write the same thing on the board as an abstract concept. That is, whatever action I do in reality, the conversation in reality, I will write it on the board. If there is a mistake in the conversation, the same will reflect on the board. Whatever is correct will also go on the board. So, we have to be very careful while talking. Let us see how to do it. Now we know that out of 464, first green plate, that is the green plate of hundreds, has to be given first because this has the highest place value. If we distribute them, how many will each person get? So, first I have to distribute the 100 place. How many did each person get? 1, 1, 1, 1. So, everyone got 1 each. Now, watch it here. I distributed the 100th place. To how many? To 4 people. When I did that, how many did each one get? 1. What do we have here? How many hundreds did I have? I had 4. When I distributed them, how many hundreds were given out? This is how many were given out. This is what I had. This is what each one got. This is what is given out. What is meant by given out? I had something, I gave them. We have seen in subtraction, if I give away what I have, what do? We subtract. I had 400s and I gave away the 400s. So, how many hundreds are left with me? Nothing. Do we have any hundreds to give away? No. But what do I have? I have 6 tens. Is that correct? Shall we see? I have 6 tens. This is the tens place. I have 6. Now I have to distribute that. Let us give them away. So each one gets. Can we give 2? Let us see. Let us give 2 and see. Oh, one person does not get any. So we cannot give 2 each. This is what children should understand. Let us give 1 each and see. 1, 1, 1, 1 10. So totally 4 tens are given out. I have 2 tens left. Therefore, how many tens did I have? 6 tens. How many tens did I give away? I gave away 4. How many tens did each get? Each got 110. Isn't it right? Each has got 110. One of the six tens I had, four tens are given out. Therefore, I have to subtract. When I subtract, how many tens are left? 1, 2. So I have two tens left. I am unable to give out these tens. But this exercise or the aim of this activity is to empty everything I have. I have two tens and it is not going away. Still there. I have four more units. I am unable to give out these two tens, but I must give it out. It has to be empty. What should I do? All right. If I take these tens to the bank will give me change. I will go to the bank. If I give two tens to the bank, what will they give me? They give me the change in units. How many units will they give me? How many units for 110? 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. How much did I give? Two tens. Therefore, I should get 10 more. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now I have 20 units. 20 units. This is what I got when I gave them two tens. But I already have 4 units. So totally, how many units do I have? I have 24 units. Let us see it here now. I had two tens. I gave it to the bank. Bank gave me 20 units. Along with those 20 units, I have 4 units. So I have 24 units. So can I distribute these 24 units? Yes, I can. But how? Let me begin by giving 2 each. There are many left. I will give them 2 more to each one. I have some more left. I will give out 1 now. Some more are left. Now everything is empty. In this case, children can distribute 1 each or 2 each or 3 each. It depends on their ability to think. They know if they give out 3 each also, there will be something left. So, they can distribute it in any which way they want. We should not put a condition that they should give out only one at a time. Now, everything is distributed. 24 units are given out. How many has everyone got? 1, 2, 3, 4, 5, 6. First person got 6. Second one got 1, 2, 3, 4, 5, 6. So we just have to check if everyone has got equal number. 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So what we did in the concrete stage, let us write it here. How many did each one get? They got 6. How many did I have? 24. Did I give out all 24? Yes. What am I left with? Nothing. When I distributed all 24 I had, everyone got 6. I had 464 to begin with, but now I have nothing left. How much did everyone get? 116. Abstract form. Let us see what we got in the concrete form. 100, 10 and 6. 116, 100, 10, 6. Everyone got 116. So, we saw this in the concrete stage and in the abstract stages. In division, we also have the representational form, but usually the representation form is not used. That is because when the divisor gets large, the representational form becomes difficult to write in our square line book for paucity of space. That is the reason why we go from concrete to abstract stage through this conversation. We complete the activity. Now let us do the division problem with play money. This is a 4-digit number. What is this activity? I have 1000, 1020, and 1, 2, 3, 4, 5. That is 1025. I have this amount. I have to distribute it to 5 people. 1, 2, 3, 4, 5. I have to give it out to 5 people. In our classroom, we can give it to 5 children. How do we give it out? Let us put the money down here. 1025. Here, we do not have any hundreds. We do not have a hundred down here. Let us write the place values, units, tens, hundreds, thousand. When we looked at the process of division, we understood an important rule or a framework. Division has to be done according to the place value. That is the reason why we write the place value every time we do division. We have 1025. Among how many people do we have to share it? We have to share it with 5 people. This is the number of people. This is the amount I have. So, when we begin to distribute, we have the story of jackfruit. Everyone knows it. First, we put down the heaviest item. That is, we have to begin dividing from the biggest place. Let us begin. To share with 5 people, how many 1000 rupees notes do we have? Just one. How do you give one note to 5 people? I can give one note to one person only. So this cannot be shared. But I must share it, right? So what do we do? Let us write down how much would each person get because we are sharing the thousands place. If you share 1000 among 5 people, how much would each get? Let us ask them. How many 1000 notes did you get? What is the answer? Nothing. Zero. Nil. So nobody got anything. But I have to give away 1000. What should I do? We should go to the bank. When I go to the bank, what change did I get? Let us see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I got 10 notes of 100. Now, bank and whoever went to the bank to get the change, how much did the bank give? The receiver should count the change. The bank may have counted it, but when we go to withdraw money or for change, we always count the money. Everyone should count it here. Remember, trust but verify. That means verify even if you trust the other person. Because the person who gave the change gives 9 or 11 notes, our answer will be different and that will be wrong. That will be a wrong answer for the problem. Though the bank counts it, the receiver of the money should count it again. We have counted it. Nobody got anything from 1000 rupees, but we have not spent the 1000 rupees either. Did we spend? We did not spend it, but we took it to the bank. What did we get from the bank? 10 notes of 100. Right? We are writing what is here. We did not spend the 1000 by sharing it. It did not disappear because we distributed it. But we went to the bank and got 10 notes of 100. Then, can we give out 10 notes of hundreds to all? Let us see. One each. Will everyone get one each? Yes. Let us try to give one more. If we give one more, yes, all are given out. I have nothing left of 100 rupees notes. All my 100 rupee notes are empty, nothing left. How many hundreds did everyone get? Let us ask. How many did you get? One, two. Did everyone get two or did someone get more? Everyone got two only. Let us write it here. How many did each get? It is two. Did I exhaust all 100 rupees notes? Yes, I did. If I subtract, I do not have any 100 note. What am I left with? I have two notes of 10. How do we write it? I have two notes of 10. We have to share these two notes. There are two notes and there are 5 people. How is that possible? We cannot give two 10 rupee notes to 5 people. If you give one each, only two of them will get it. What shall we do? How many tens did everyone get? Did anyone get? No, we cannot give it. What should I do? Again, I should go to the bank. If I go to the bank for 10 rupees, what change do I get? Do I get 100 or 1,000 or 1 rupee? Children will know it. If I give the tens, I get 20 notes of 1 rupee. 20 notes. Let us count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I got 20 notes. But what happened to the 10 rupee notes? Did anyone get any of that? Let us ask, how many did you get? Nothing. We didn't get anything. Did I share 10 rupee notes? Did I spend it? No. What did I do? I went to the bank and got 20 of 1 rupee. Apart from that, how many 1 rupee notes did I have already? 1, 2, 3, 4, 5. I had 5 of 1 rupee notes. So now totally I have 25 rupees. Can we distribute these 25 rupees? I have 5 people. 25 rupees would mean let us give 2 each. Everyone gets 2. And then let us give 2 more. Now everyone has 4 rupee notes. Let us give 1 more and see. And 1. Now all 1 rupee notes are gone. Therefore, how many did each one get? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So everyone got 5 1 rupee notes? Yes, everyone got 5 each. So everyone got it equally. So we can write 5 here. I have exhausted all 25 1 rupee notes. What am I left with? Do I have anything left? I have nothing, that is 0. Now, we have distributed 1025 rupees to 5 people equally. The problem of division, this is the process we have learnt through games and we have written it in the abstract. I have conceptually put it on the board. When we practice it in the square line books, we can write it according to the place value. We can see that in the square line book. Usually, how do children solve this problem? 1025, it has to be divided by 5. Often, children take division for tables. They think if you know table 5, I can do it easily. Let me start. 5 twos are 10, 0. 5 fives are 25, subtract 25, so 0. Most often, children give this answer because they have not done according to the place value. We got 205 here, but we got 25 here. Why? Children concentrate on mugged up table only. And without knowing the concept of division, if they base it on the table, they get wrong answer as a result of wrong concept. Hence, we should do the division with concrete stage, understand the concept, and then if we do it in the abstract form, children will understand it properly. In this problem, 1025 rupees were to be shared among 5 people. We need to observe something here. At every point, what question do we ask and what is the answer? Look here. How much do I have? How much did I distribute? How much did each get? What is left with me? How much do I have? How much did each get? How much did I spend? What is left with me? This is being repeated again and again. Same set of questions, right? How much do I have? How much did each get? How much did I spend? How much is remaining? How much do I have? How much did each get? How much did I spend? How much do I have remaining? So, we need to ask these questions about every place value and keep getting answers till we reach the last place. By doing it in this way, it helps in solving a division problem through conversation. We can see it that way. Now, we have seen division of 1025 by 5. Let us look at a few more examples because the speciality of this division operation is we are dividing it according to place value. So every place, what we have, we are off to distribute. When we distribute, did everyone get something in every place value? We have to check this. Let us take another example. 391 divided by 3. Let us use the required conversation. Place value to be noted first. First, the hundreds. I have 3 hundreds. I have distributed it to 3 people. If I distribute it to everyone, everyone would get 100 each. So, I exhaust all hundreds I had. Nothing is left. What do I have now? I have 9 10 rupees. 9 notes of 10. If I have to give it out equally, how many will each get? Everyone gets 3 10 rupees. Do I finish all the 10 that I have? Multiply 3 and 3, so I have 9. It means after giving equal amounts, I have nothing left. What else do I have? I have 1 rupee. Who should I give this 1 rupee to? It is to 3 people. When I give 1 rupee to 3 people, how many 1 rupee notes did each one get? Do they get it? I have 1 rupee only. I have to give it to 3 people. Possible? No. So, each one gets nothing. But did we spend 1 rupee? No, because nobody got it and it remains with me. Most common mistake by children is they forget writing this 0. They get the remainder once this 1 is brought down here. They do not continue the process. Let us take another example. What did we see in this example? I had 3 hundreds place, 9 in tens place, and 1 in the units place. How much did everyone get? In every place. 3 in the tens place, 1 in hundreds, and nothing in the units place. Let us take another example. 5,445. This money has to be equally shared among 5 people. First, let us write the place value unit 10, 100, 1000. 4 places with 4 place value. First place is 1000. In 1000 place, there are 5 people and I have 5 notes. So everyone gets 1 note each. And I empty all 1000 notes. I have nothing. Everything is given out. Each one got 1 note. What do I have now? I have 400 rupees notes. How do I distribute 400 rupees to 5 people? How many 100 rupee note will each one get? Will they get it? No, 4 is less than 5. Nobody gets any 100 note. So I cannot give 100 to anybody. But I still have 400 notes and I did not spend it. If I subtract 0 from 4, I am left with 4 notes. I have to exhaust all these 400 notes. How do I do it? In order to do that, I go to the bank again. What will the bank give me? They give 40 of 10 rupee notes. 40 of tens. But I already have 4 10 notes. I already had 4. Hence, I have 40 plus 4. 44 10 rupees notes. How many 10 rupees notes may each person get? Everyone gets at least 8 notes of 10 rupees. So, 40 notes of 10 are given away. Therefore, how many 10 rupee notes are left with me? 4. I have 4 10 rupees notes. I cannot give 4 notes to 5 people, but I must distribute the entire amount fully. What should I do to empty this? I should go to the bank, and if I take change, how much change will I get? I will get 40 of 1 rupee notes. I already have 5 1 rupee notes. Totally, I have 45 notes of 1 rupee. Therefore, how many 1 rupee notes will each one get? 9 notes each are given out. Therefore, how much money am I left out of 5,445? After giving out these 45 units, I have nothing left. What can we see in this example? Nobody got anything in the 100th place. Earlier, we did not get any in the units place. In the earlier sum, before these two problems, 1025 divided by 5. What did we see in this problem? Unit 10, 100, 1000. In which place did we not get any money? Nothing in 1000, 2 in 100, nothing in tens place, and we got 5 in the units place. In every example that we saw, in some cases, we got nothing in the units place, nothing in the hundreds place, nothing here in the thousand place, and nothing in the tens place. That is, when teachers manage a classroom and prepare for a lesson, they need to keep such examples in mind and teach with many different examples. Then their conceptual understanding becomes strong and misconceptions or wrong understanding are unlikely to occur. When teachers come prepared to a classroom, conceptual understanding becomes very strong. That is important for division. Now, let us look at some of the facts, division facts. That is what we call them. Let us take this as an example. 20 divided by 5. We can write it in two different ways. If we divide 20 by 5, what do we get as an answer? 4. If we divide 20 by 5, we get 4. If we divide 20 by 4, we get 5. If we multiply 4 and 5, we get 20. From one division fact, we have one division fact and another multiplication fact. One fact about division and another fact about multiplication. We see these facts. We have seen it earlier in addition and subtraction. We saw in the earlier videos. Now, let us look at some of the rules of division. First, if I divide 0 by 5, that is, if I have nothing, but I have to share it among 5 people, is it possible? How much will each get? I have nothing. I have to give nothing to 5 people. That means each one got nothing. I have 5 items. I have to give it to one person. So, how much did each get? I have 5 items, 5 square counters, 5 rupees. I have to give it to just one person. So, I can give all of them to him. Then, everyone gets 5 counters or 5 rupees, whatever. I have 5 coins of 1 rupee, and if I give it to 5 people, how much will each person get? Everyone gets 1 coin each. I have 5 rupees, and if I give it to 0 people, I do not give it at all. How much did everyone get? There is nobody there. Nobody is there, and I did not give it to anyone. Therefore, what did they get? Since there is nobody, how can we say how much did each one get? We cannot say. So, here it has no answer. We shall visit this in the higher classes. This is called infinity. These are some rules in division. If children remember these, they can do the operation very easily. In division so far, we have seen the concrete form and the abstract form. We mentioned that representational level or the R stage does not exist. That is because as we distribute to more people, we cannot represent the whole group. I will use an example. I have 393 rupees. I have to give it to three people. Who are these three people? This is one. This is the second person. This is the third. One, two, three. In 393 units, tens, hundreds. These three places are there. What did we say during division? Everyone should get something in each place. They have to get something. Sometimes they will get something, sometimes they don't get it. If they don't get it, we have to show it that they did not get anything. Let us see in this example, if everyone has to get in all places, we can look at it this way: units, tens, hundreds. I have three notes of 100. Why should we begin from hundreds? That is because in division, we have to start from the highest place. 100 is the highest place value here. When we begin here, we have 3 in hundreds and we have to give it to 3 people. So each one gets 100 rupees. Each one gets 1. I have given all 100 notes I have. Now I have 9 notes of 10 rupees. How much will each person get? 9 notes to be given out to 3 people. So each one gets 3 10 rupees notes. Each person gets 3 notes. That's a possibility. Person 2 gets 3 10 rupees notes. Person 2 also gets 3 10 rupee notes. Person 3 also gets 10 rupees notes. So 3, 6, 9. I have exhausted all 10 rupees notes. Now I have 3 1 rupee notes. Everyone gets 1 rupee note. This is how we solve it by representation. Similarly, instead of 3 people, if we were to share it to 13 people, we will have no space to write 13 times in this representation method. Or we may have to turn the page and see how to distribute. So, in the representation stage, when people to be distributed are in a large number, the representation form extends and makes it bulky and makes it cumbersome to write in the square line notebook. Hence, we avoid the representation stage as much as possible. We do division from concrete to abstract. We do it through conversation. So, how much did each one get? One got 100, 30, and 1. So, 131. Did each one get the same? 131? Same here. 131. So, everyone got 131. And if we add it all up, we get 393. This is the pictorial stage. That is, it can be called representational, but unlike the previous representational stage, we didn't make 9 groups. A house with 9 rooms, we can show it in that way also, but I will continue here. This is 100, this is 10, this is unit. 100, 10, unit. 9 squares in every house. In the hundreds place, how many rooms are full? Just one, since there is just 100. 3 squares in the place of 10, just one square in the units. Similarly, 100 here and here, 3 tens and 1 unit each here. Even here, I got 131, 131 even here, and 131. So, if we use pictorial and representational stage to show distribution of 393 to 3 people, each one will get 131. This may be seen very clearly when we use the square line notebook and solve a problem. Now, let us see how to use the concept of division in our daily life. How do we apply it to our daily life? First, distributing to a group. It is my birthday. I have 60 chocolates. There are 20 students in my school. I have to distribute it to all 20. How many will each get? In the group, I am distributing what I have. This is one example. Given objects. I have been given 12 yellow cubes. How many groups of 3 can you make? Now, this is not exactly a distribution problem, but this is repeated subtraction. We have already seen it. When we make the group itself, it will be 3. What are we trying to find out? To how many people are we giving? If the same is to be distributed equally to 4 people, how many would each get will be known only after giving. So, there is a difference between making equal groups and equal distribution. We have to understand that. Similarly, money. When we have money, how do we distribute it? There is a difference here as well. We try to look at the highest valued note and distribute that first, the note with the highest denomination. We follow this method even while counting the money. If I have 5 notes of 2000 and 1 note of 500 and 80 notes of 10 rupees and 100 notes of 1 rupee, we start counting from the highest valued note of the highest denomination. Similarly, while distribution also, we try to give out the highest valued note. Another way of looking at division is we divide the entire given object into multiple equal parts and distribute among people. I may have a pizza or a chapati or a dosa. I made 2 pieces and shared. That is also sharing, but it occurs in fractions. This type of sharing is applicable division as well, but it will be treated as a fraction. Let us see that in the next video. Why do children have misconceptions in division? We saw some examples. If we do not divide according to place value, and if I divide the given number according to place value, how much did each one get in each place? Ignoring this detail and mugging the tables well, division is knowing the tables well. That is a problem. If they proceed with this thinking, if I divide after learning tables, there will be a mistake. 1025 divided by 5 may give the answer as 25. When you think about the place value, the answer may be 205. The reason for misconception is not dividing according to place value. That is to be remembered. In this video, we have seen how to teach the concept of division to the children in a joyful and a playful method.